Hello, what is up? My name is Mike Wada and welcome to Radical Academy. So in this video, we'll be looking at physics, and this is a topic that I started off under momentum. So it's kind of a continuation from where we left from, and I believe that if you have been following some of my videos, you have watched where I showcased and talked about what momentum is all about, and did some we did some calculations. Okay, so now without much further ado, if you're new to my channel, please don't forget to subscribe and also like and share and smash the like button, the subscription button, so that whenever I post any new content, you'll be the first person to receive or the update. Okay, so now what is it that you'll be looking at today? Now in this video, we'll be looking at what is known as okay, so we'll be looking at kinetic energy as well as work. So when we talk about kinetic energy can be defined, okay, kinetic energy can be defined in form of as the, which you can say K equals to the energy or something like that possessed by okay, so kinetic energy can be the energy that is possessed by an object that is moving in motion. So we see most of these objects such as vehicles, or even us human beings, when you're moving from one place to the other place, we are normally possessing what is called kinetic energy. So understand that kinetic energy is the energy possessed by those objects that are in motion. Now, what is the formula for kinetic energy? Now, before we get to the formula of what kinetic energy is all about, kinetic energy can be conceptualized or understood from the concept of Isaac Newton's, second law of motion. So, which we saw even in the previous session. So, if you have not seen my video, or if you have not watched my video, please go back on my YouTube channel, go and search for Radical Academy. You'll be able to find the videos about momentum, as well as some of the calculation that I performed there. And then once you watch the video, you'll be able to understand how we were able to derive the formula for momentum, which is just the momentum equals to the product of a mass and velocity of an object which is set in motion. Okay, so now we are saying that an object that has got momentum has got also some kinetic energy, because momentum has to do with things that are set in motion. So we are saying that any object that is moving in motion possesses kinetic energy, and then any object that is set in motion also has a property of momentum, which is meaning the speed of an object multiplied by how heavy that object is. So that kind of there's a relationship between momentum as well as a kinetic energy. So we'll see how we can be able to derive or rather kind of merge the relationship between momentum as well as kinetic energy. So just stick around and follow how these things goes about. So now we can see that for momentum, which is P, okay, we saw that momentum, which has a formula for mass and velocity, equals to mv, where m is the mass in kg, as well as velocity in meters per second. Okay, so kg dot. Okay. So those are the units for momentum. So, and by the way, make sure that we begin now to understand that units are very important in science or in every aspect of a scientific subject. Okay, more especially in physics. as well as chemists, including biology, make sure that we begin now to be applying, okay, and to be able to understand why we must be able to include some of the units, fundamentals, as well as our derived units. So please don't forget that, okay? So I'm so super excited to teach you this course because physics is one of my best, favorite subject, okay, that I've been enjoying after I've graduated from university as well as also from high school. So it's really interesting because it kind of tells you to think more and just logically, okay. It's not just about knowing the formula, but what is the implication of the quantities that you are using in the formula. Why are you using them, and why some of them might be negative or anything like that, okay. So we need to begin to be able to appreciate and understand the cardinality of the units, as well as how precise we should be in our calculation when we try to understand the units, how important they are. Okay, so now let's keep going. So we should note that if an object has a momentum, it has also kinetic energy. Okay, so that is a key number one. Okay, so an object that has got momentum, which we have defined to be the product of mass as well as its velocity, meaning how much is the object moving in terms of the change in velocity, which is acceleration, and then how heavy the object is. So please don't forget that those are the definition of momentum. Okay, so now when we talk about kinetic energy and momentum, these are just one form of the other. Okay, so an object, remember, I'm repeating this so that it's get into our brains. Okay, so an object with momentum has also kinetic energy. Now we should also know what is the formula for this kinetic energy. Okay, so the formula for kinetic energy equals to half multiplied by the mass of an object, and then multiplied by the velocity of an object squared. Okay, so when we get this formula, make sure that the velocity is squared. And by the way, the fact that this kinetic energy is just half mv squared. Okay, so an object might start from rest, okay, which is meaning initial velocity of 0, and then as it moves on, it increases in terms of velocity. Okay, so as it increases in terms of velocity, then that object might attain what is known as a final velocity, with which the object will reach at. Okay, now the fact that most of the object or the vehicles, the cars, or any object that we might think of may start from rest. Okay, if it starts from rest, then we are saying that an object, its initial velocity is 0. Okay, so we'll see where the concept is going. Okay, but for now, I want you just to know that the kinetic energy formula is just as simple as half multiplied by the mass of that object multiplied by its final velocity from the point it started moving from rest. Okay, so assuming that rest means that the initial velocity is 0, so that kind of gives us just that mass. Okay, I mean v squared. Okay, which is the final velocity. Okay, so now after we understand now what is the formula for this kinetic energy. Then now we are saying that what is the unit, okay, of kinetic energy. Now kinetic energy is measured in joules, which can be symbolized by the letter U. Okay, so in joules, or so this is the smallest unit. Okay, we can also have a kilojoule. Okay, a kilojoule, which is just in kilojoule. Okay, so this is the largest unit of energy, and then that is a smaller unit of energy. So whenever, make sure that we are able to understand how to convert from joules to kilojoules, and also vice versa, from kilojoules to joules, or joules to kilojoules. Okay, so 1 kilojoule equals to 1000 joules. Okay, equals to 1000 joules. So if I'm given that, for instance, maybe let's say 0.5. Okay, so if you are given, for instance, 0.5 joules, then how can you be able to convert from joules to kilojoules? Okay, so this can be seen as 0.5 joules. You multiply by, you get now what is known as the conversion unit. Okay, so again on this point, I want to emphasize that for those that have not been following, I released a video that spoke about unit conversion in mathematics, so you can go and check it out on my Facebook page, Learn with Mike Warrior, or you can go to YouTube and search for Radical Academy. You'll be able to find my video that talks about unit conversion or conversion of units. Okay, so go and watch the video, and then you can be able now to understand what I'm just going to show you over this one on how you can convert, or just vice versa, from kilojoules to joules. Okay, so I hope you're following. Okay, so what I do is I'll say 1 kilojoule over 1000 joules. Okay, so what I'm doing is I'm just making a conversion factor or the conversion unit. Okay, or I swap now the 1000 goes as a becomes as a numerator, and then this is, and then the 1 kilojoule becomes as a denominator. Okay. So now what I'm going to do is I'll choose between the two converters. Okay, the two converters. Okay, which one am I going to multiply with the 0.5 joules, so that I cancel the joule and then only remain with the kilojoule in which I want to convert the number into. Okay, so you can see that if I put, what I need is to make sure that the joule is down here. When it is down here, then I'm going to use this one, okay? Because I want the joule and the joule to cancel each other, okay? So this is going to be 1000 joules over 1 kilojoules. Okay, so now you can see this and that cancels, okay? And you remain with it 1 kilojoule multiplied by that. Over, then there is this 1000. Okay, so this is now going to be okay, so this is going to be just the, this is going to be 0, 1, 2, 3, so I have the decimal. Okay, so that is how you answer or how you convert when you are given such a scenario. So you might not just be given a scenario where the units are just joules. So you can face a challenge whereby they are telling you to say, can you give your answer in kilojoules, okay, but not the joules, okay? So make sure that you understand how to do that, okay? But if you wanna fully understand how to convert between units, different and various units, please don't forget to go to my YouTube channel and check for the exact video which just talks about how to convert units. Okay, so I hope that has been understood, and let's now move to the next work. Okay, so now let us look at an example where we will be able to derive what is known as the change in kinetic energy. Now, we begin by saying that if we have a certain object, okay, a certain object that has got a mass of m, and then this object is now acted on by a steady force F. Okay, so we've got the force F, so that its velocity, the velocity now changes from initial to final over a distance s, or which we can just call displacement. Okay, now if we want to come up with the formula that talks about the change in kinetic energy from the initial point of a movement to the final point of a destination, then we're supposed to understand how we can come up with that formula. And the formula is simple. I want you just to follow and try to understand everything that I'm going to say right now. Okay, so now let's begin. Now, the fact that we know, the idea we know that an object must undergo acceleration, which is just, let's say, for instance, final velocity according to Newton's laws of motion, and then these are governed by some of the equation, like the equation that I'm going to just put in a minute, which is v squared equals to u squared plus 2 multiplied by the acceleration as well as the displacement, which is the distance over which the object has moved from the initial point to the final point, which is a change in what is this in what the change in velocity. Now the change in displacement, sorry. Okay, so now we can make the acceleration the subjective formula. Now we are saying that most of these objects, they the momentum as well as the kinetic energy, they are obtained or they are influenced by certain forces. Okay, so we kind of try to say that we must be able to understand the concept of force, okay, from Newton's second law of motion, which is just okay. So this force is what is causing the motion of the particular object, okay, of a certain mass. So from this point, we are going to make the subjective formula. So this is going to be v squared, this comes this side, minus u squared, and then that remains over there. Then we get 2as. Now from there, we can now divide both sides by we can divide both sides by 2s, 2s. Okay. Now once we do that, then this, or just we can just 2s, so that this and this goes. Okay. Now from there we have this squared minus u squared over 2s equals to the acceleration. So we can call this as equation number 1. So this is equation number 1. And then let's say this is equation number 2. So that's equation number 2. Now from there, what you do is we are going to substitute equation 1 into equation 2. So we are going to substitute equation 1 into equation 2, meaning that this A as a subjective formula will be fixed over there. Okay. So F equals to mass multiplied by, then A equals to this. Okay, so we grab all this and then put it where there is A. So V squared minus C squared over 2. Okay. Now once you do that, you can just further simplify as mv squared minus mu squared over 2s. Okay. Now from there, we're saying that F, you can now get rid of the s, so you can just cross multiply. This is going to be F dot s equals to okay. Now this denominator 2 can be just simplified as half. Okay, so half or you can just say half then v squared minus c squared. Okay, which can be half now. What you're going to do is that if an object started from 0, initial velocity of the object, maybe the object started from rest, meaning the initial velocity of that object is 0. Now, when you say the initial velocity of that object is 0, then now that's a key concept. Since initial velocity equals 0, then this is going to be F dot S half m v squared minus half now what is going to happen over here is that whatever that we multiply with this, all these things